So today we're going to look at something you think you know really well, but you will kind of figure out quickly that there's a lot more to it than you ever realized. And that's rectangles, rhombuses, and squares. Especially rectangles and squares, those are things that you guys have known about since kindergarten. And some of you use the terms interchangeably, but they are not the same thing. All right? For just kind of an organizational chart here, and we're going to expand on this organizational chart tomorrow, but all quadrilaterals, if we consider this oval to be all quadrilaterals, we know that parallelograms are just one subset of that. There are plenty of parallel or quadrilaterals out there that are not parallelograms. But we do have some special parallelograms. We have some parallelograms that are equiangular, which means all four angles are the same, which means all four angles are right angles. Those are rectangles. We have some parallelograms that are equilateral. Again, lateral meaning sides, all four sides are the same. Those are rhombuses. And we have some that are both equilateral and equiangular. That's where these two overlap, and those are our squares. So if something is a square, it's also a rectangle, but if something's a rectangle doesn't necessarily mean it's a square. Same with rhombuses. So rectangles, rhombuses, and squares have all the properties of parallelograms because they are parallelograms, but they're going to get special properties as well. And so where we spent last week talking about our properties of parallelograms, like both pairs of opposite sides congruent, both pairs of opposite sides parallel, both pairs of opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. Those are our 5 basic properties of parallelograms. Those apply to all rectangles, rhombuses, and squares as well. Those properties automatically apply because these things are parallelograms. What's going to happen is these shapes are going to get their own special properties. They're going to help us define them. And we already see some of those special properties right here. Rectangles, all angles congruent. Not just opposite angles, but all angles congruent. Rhombuses, not just opposite sides congruent, all sides congruent. So the opposite sides are still congruent well, but not all 4 are. And square has all angles and all sides congruent. Okay? Rectangle and rhombus properties. Now, there are additional properties, and this is something you're really going to need to know. You might want to jot these properties down. If not, you might want to print out this page and make sure you keep it handy. Or if you took notes in the vocab, which 3 or 4 of you did, you might be okay. But these are properties you will be held accountable for knowing. So make sure that you do something to help yourself remember them. Now, this is just regular parallelograms, nothing new here. This is stuff we've already learned. Opposite sides and angles are congruent. Opposite sides parallel, diagonals bisect, consecutive angles supplementary. That's last week. That's what we spent last week doing. Rhombuses have the following properties. We add to it that all sides are congruent. But there are 2 other properties that are not as obvious that we get pretty quickly, and they're both dealing with the diagonals. The diagonals in a rhombus are also perpendicular to one another. In other words, they intersect to form a right angle. So all 4 sides are congruent. But the diagonals intersect to form a right angle. They still bisect each other because it's a parallelogram, so that's still true. But they also bisect the angles. In a regular parallelogram, the diagonals are not perpendicular. They do not bisect the angles. But in rhombus, they do. So all 4 sides congruent, that's the easy one. The one that's trickier is diagonals are perpendicular and diagonals bisect the angle. Rectangle is a bit easier. Consecutive sides are perpendicular. All angles are the same, equiangular, however you want to put it. Right angles everywhere. And the diagonals this time are congruent. So if those diagonals are congruent, that's an indication we may have a rectangle. And then a square has all the properties of both rhombuses and rectangles. All the properties of both. So that means the diagonals are perpendicular, they're congruent, they bisect the angles. Each of those angles is a 45, because these are right angles. All right. Squares have everything. Everything's going on with a square. And these are our critical properties. Now, one of the things I try to do, because I think it's the easiest, is to kind of focus on the diagonals. I like to focus on the diagonals as a way of distinguishing the type of parallelogram. Basically, what it comes down to this: if we're working in the coordinate plane, and we will be today working in the coordinate plane, just like we were before, in the last part of the unit, we need to take 4 measurements to prove what it was, or sometimes as few as 2 if we did diagonals bisect each other. Now it's going to take at least 6 measurements, and sometimes 8 to prove what kind of quadrilateral we have, depending on what measurements we take. But our easiest path is to look at the diagonals. The easiest path when working in the coordinate plane is to work only with the diagonals. The way we do that path is pretty simple. We start by seeing if the diagonals bisect each other. Okay? If the diagonals bisect each other, it means it's a parallelogram. That's good. But if we look at our picture, just knowing it's a parallelogram, it might be a rectangle, it might be a rhombus, it might be a square, it might just be a plain old parallelogram. We don't know enough yet. But we start by determining if it's a parallelogram or not. Because if it's not a parallelogram, there's no sense even checking to see if it's a rectangle, rhombus, or square. It can't be. So the diagonals don't bisect each other, which means they have the same midpoint, then it's no good. So we start with the midpoint formula. Then these other two could happen in either order. It's kind of up to you. But I usually do distance formula next. Are the diagonals congruent? If I already know they bisect each other, I know it's a parallelogram. Now I find out they're congruent, I know it's a rectangle. Might be a square, might not be. If they aren't congruent, I know it's not a rectangle or a square. So we can narrow it down one way or the other by knowing if the diagonals are congruent. Then finally, number 3, are the diagonals perpendicular? And that's measured through slope in the coordinate plane. And again, depending on what you find out, we can determine exactly what type of shape it is. So we could actually make up a little chart here if we wanted to. Okay? So we start with, are they bisecting each other? If they bisect only, well, I'm not quite sure how I want to organize this right now, so we could make a chart. A flow chart would probably be easier. Excuse me. To start out, do they bisect each other? Yes, then it's a parallelogram. Are they congruent? If it's yes, it's a rectangle, maybe a square. If it's no, it's not a rectangle or a square. Are they perpendicular? If yes, it's a rhombus, maybe a square. No, it's not a rhombus or a square. And then, depending if these are both yeses, then it's a square. Excuse me. I need to get a drink here in a second. So, let's kind of quiz ourselves on this a little bit. This shape is a rhombus. What can you tell me about segments AC and segment BD? The fact that that's a rhombus. There are two facts, well, actually three facts we should know about AC and BD. Tell me one of them. Yeah, what do you guys think? Okay, they're perpendicular, yes. Those diagonals are perpendicular. What's another fact? They do bisect each other because it's a parallelogram, and so the properties of parallelograms apply. So we know it's a right angle. We know they bisect each other. What else do we know? It's a third property, or is a second property for rhombuses that's special. Well, they're clearly not the same length, are they? No, they're clearly not congruent. That would make it a square if it was, yeah. They bisect the angles. And this is one we can't do in the coordinate plane. But it does work here. In fact, it's pretty clear that these are all four congruent triangles, aren't they, when it's a rhombus? All four triangles are exactly congruent. That normally doesn't happen in a regular parallelogram, does it? All four triangles are not congruent in a regular parallelogram, but in the rhombus they are. And for some of you, rhombus may be a new word. You're used to calling it a diamond. But rhombus is the technical geometric term. Again, this kind of breaks it down. Keys determine a type of quadrilateral. First, do the diagonals bisect each other? Are they congruent? Are they perpendicular? Okay? If you, in step one, find out that it is a parallelogram, that they do bisect each other, you must do both steps 2 and 3. If step 1, the answer is no, the diagonals do not bisect each other, then we don't do either step 2 or 3. Not for now. Tomorrow, actually, we'll pick up another property that we might be able to do. Diagonals don't bisect each other. We're going to learn about non-parallelogram shapes tomorrow. Special non-parallelogram quadrilaterals. All right? Yeah, okay. Now, like it says, you could always work with the sides if you want to. There's some people who get confused with the diagonal rules. But it takes many more measurements, or at least 2 more measurements. You'll have to take probably 8 measurements to work with the sides. If you choose to work with the sides, start with slopes, because slopes are the quickest formula. Are the opposite sides parallel? And are consecutive sides perpendicular or not? You'll be able to tell that from the slope, whether they're parallel or perpendicular. But then you have to see if the side lengths are all the same or not, and that's distance formula. So it takes a little more work, because you have to find the slopes of all 4 sides and the lengths of all 4 sides. We don't worry about the midpoints of the sides ever with parallelograms and stuff. So you have to kind of look at doing more measurements if you're going to work with the sides in the coordinate plane. So here's the shape. What is it? Rectangle, rhombus, square, parallelogram, none of the above? Okay. You can't just tell by looking at the picture and seeing. You actually have to run the calculations. Don't try to do it, well, I graphed it, and obviously it's a no. You must prove it using the algebra. Some of you on the quiz didn't do a very good job of that. Most people did okay, but some of you really did not. You did not prove it. You might have measured just two sides. You said, oh, these two sides are parallel, parallelogram. No, one pair of sides being parallel is not enough. You got to take enough measurements. So I have A is at 3, -2. B is at 1, 4. C is at 5, 6. And D is at 7, 0. Oops. Sorry, let's try that again. Okay. There are my 4 points. Again, the first thing I do, is it a parallelogram or isn't it? If it's not, I can stop. I mean, we'll do one check and be done. So check if it's a parallelogram. Check for parallelogram. That means midpoints of the diagonals. Remember, we're going to work with these two diagonals, BD and AC. So midpoint, again, every time we make a measurement, we write down what we're measuring. The midpoint of AC uh, 3 plus 5 over 2, -2 plus 6 over 2. We add and divide by 2 for the midpoints. 3 plus 5 is 8 over 2 is 4. -2 plus 6 is 4 over 2 is 2. Midpoint of BD, 1 plus 7 over 2, 4 plus 0 over 2, or 4, 2. Aha, same midpoint. So diagonals bisect, so it's a parallelogram. Now, what kind of parallelogram is it? Just a plain old parallelogram? A rectangle parallelogram, a rhombus parallelogram, or a square parallelogram? Which one? So the next thing I'm doing is going to see if the diagonals are congruent. So AC, measuring segment AC, 3 minus 5 squared plus -2 minus 6 squared. So it's -2 squared plus -8 squared. 4 plus 64 is the square root of 68. BD, 1 plus 7 squared, or 1 minus 7 squared. I'll do that right. 3 minus 5, -2 minus 6. All right, so 1 minus 7 plus 4 minus 0 squared. So that's -6 squared plus -2 squared. 36 plus 16, 52. Oh, the diagonals are not the same. Okay? Diagonals are not congruent, therefore it is not a rectangle or a square. So from that, diagonal is not congruent. So not rectangle or square. Could still be a rhombus. Might be a plane parallelogram, might be a rhombus, don't know. So I can check to see if the diagonals are perpendicular. So the slope of AC negative 2 minus 6 over 3 minus 5. Negative 8 over negative 2 is 4. The slope of BD, 4 minus 0, 1 minus 7 is 4 over negative 6, or negative 2/3. So they are not perpendicular, not a rhombus. This is just a plain old parallelogram. That's all it is. Yeah, you may have said it, but you didn't prove it. Say that'd be like a major point problem on a test, and saying it's a parallelogram would be worth maybe a tenth of the points. The real points come from proving it. So again, not very secret. All right, it's called guessing. It's good. Good for you. And that's where your points would wind up too, in your head, not in the grade book. But anyway, you can see I have to know midpoint, slope, and distance formulas. All three of them I have to work with. And I have to know what they measure. Another problem I encountered on this last quiz for a couple people is they did everything right. They measured, they used distance formula on all four sides of the shape, showed the opposite sides have the same distance, and then concluded the opposite sides are parallel. Distance formula does not measure parallel. Distance formula measures congruence. Slope measures parallel. So you have to know the formulas, how to use them, and what they're measuring. And for these types of problems, that's a pretty typical amount of work that needs to be done for one problem. All right, select the most specific name you can use to describe the figure. Just plain old quadrilateral, parallelogram, rectangle, rhombus, square. The figure is not necessarily drawn to scale. Use the facts given to make a conclusion. What type of a shape would we have in that picture? First question you ask, are the diagonals bisecting each other? Yes, so it's at least a parallelogram. Are the diagonals congruent? Yes, they are. So it might be a rectangle, maybe not a square, maybe not. Are the diagonals perpendicular? No. Therefore, since the diagonals bisect each, so we can rule out diagonals aren't perpendicular, rhombus and square are out. We already ruled out quadrilateral. We know it's a parallelogram, but the best description is a rectangle. Okay. How about now? Given that information. Nothing about the diagonals, two pairs of congruent sides. Is that a parallelogram? No. Since it's not a parallelogram, it can't possibly be a rectangle, rhombus, or square, could it? It's a quadrilateral. That shape? Sure. It's called a kite. We'll learn more about it tomorrow. That's a kite. Here we go. The diagonals, do they bisect each other? Yes, so it is a parallelogram. Are diagonals indicated to be congruent? No, in fact, they're indicated to be different, aren't they? So it is not a rectangle, which means it cannot be a square. The question is it just a parallelogram or is it a rhombus? It's a rhombus because the diagonals are perpendicular. How about here? Okay, it is a parallelogram because the opposite sides are congruent. Any more? No. How about here? Well, it is a parallelogram because WX and YZ are both parallel and congruent. That's one of the ways you can prove it's a parallelogram. So it is a parallelogram. Is it a rectangle? Well, what do we see here? This angle is a right angle, which means this angle is a right angle, and that angle is a right angle, and that angle is a right angle. So is it a rectangle? Yes, it is. Is it a square? No. It's a rectangle. These are the types of problems you're going to have today. It looks like a really big assignment, but remember, a lot of the problems today come in groups. So what they'll do is they'll give you a picture, and they'll say, well, that's not what they'll say, but okay. So maybe the picture will be like this. And then they'll give you labeling it A, B, C, D. And I tell you this side is 8, and this angle is 35 degrees. I'll call this point here E in the center. And then I'll ask you a whole series of questions. So they say, okay, how long is BC? 8. Or what's the measure of angle DAE? 35. It's a rhombus, right? So the diagonals have to bisect each other. Or what's the measure of AED? AED? 90. Okay? And then we could, so if this is 35 and this is 90, this angle has to be 55 down here. And again, and we could figure everything out. In fact, we could even go so far as say if this is 8 and DE here is 4, how long, actually it wouldn't be 4 because that'd be a 30, 60, 90. Let's call it 3. And how long is this side here? We could use Pythagorean theorem to figure out that third side. So you'll get one picture where you have a whole lot of stuff to figure out, but then you get like 6 questions on that. So once you figured out the picture, your best bet is to draw the picture, figure it out, and then answer the questions. And the answers will come boom, boom, boom once you figure out the picture. So in a lot of those cases for those problems, you're going to want to just copy down the picture, solve out the picture, and then answer your questions. There's a lot of stuff here. For the ones that are in the coordinate plane, get a piece of graph paper. Draw the pictures. Show your work. If you're not showing your work, don't expect to get the points. This is a longer assignment tonight. With the vocab and everything, this is a long assignment. We haven't had a long one in a while. It happens. So that is it. It's like we look at the assignment sheet. Might be going, I don't know what this. Oops, wrong page. Here we go. 4 through 50 even, 51, 55, 61, 65, and 66. Again, like I said, don't freak out about that because, yeah, just like any other day. Look, the other day we had an assignment. The other day we had an assignment with 4 problems on it, right? And you got 3 points for that. So today it's a longer one. Don't be like, oh, I'm not going to do that much just for the 3 points. This is just as important for your learning as anything else. You need this practice. It's not about the points, it's about the practice. I'm not going to beg you. I'm telling you it's what you need to do. So don't be all like, no, I'm just not going to, I'm going to skip that homework. You're cutting your own throat if you do so. In a lot of ways with this whole, because this is a quick unit. If you check the assignment sheet, you'll note Then our benchmark on this is already on Friday, and we have a day off in the middle for EPASS testing. We only have a 10-minute class that day. Yeah. Just a reminder for everybody also, please remember, for your testing this week, you will need your own scientific calculator. They may have a few in the classroom, but don't count on a classroom set. Bring your own scientific calculator for that test. You will not be allowed to have any other electronic device on your person during the test. On you. Okay? You may not have a phone or an iPad in your pocket. If you do, it invalidates the test and you will need to retake the test. Okay, they throw the test out and you have to redo it at a later time. You can't have an iPad in your pocket.
Yeah, you can.
iPod. Well,
Big pockets.
I've seen some people with some big pockets.
You could have a mini, but...
Yeah. Some of the Samsung Galaxy phones are about as big as a mini. So, I mean, some of the big ones?
Those are the notebooks.
Yeah, they're pretty big. All right, so just remember, keep it. We got that test coming on Thursday. That's a big one. Determines a lot of your course placement for next year.